So today we are going to discuss about the statistical quality control. Statistical quality control means using statistics to control the quality of the output of an organization. And here you can see that the least progressive process and the most progressive process. Least progressive process means that you will inspect the output that we refer in our previous lecture as the quality control. And continuous improvement, the most progressive process. This is known as the TQM, total quality management, or we refer to as the quality assurance. And when you will produce the product from beginning to end, there is a process control, inspection and corrective actions during the production. This is also one of the components of the continuous quality improvement. But only inspection after finishing the output is outdated, and this one is updated, total quality management. Quality built into the process, and inspection and correcting actions during the production, process control. So which one will you apply in your company? The most progressive one or the least progressive one?
Most progressive one.
So we will apply TQM in our organization. However, there are some inspections you have to make. Say, for an example, when you are taking inputs or raw materials from outside, what you have to do, you have to check the quality. And as per the Deming principles, if the quality of the inputs is not good, that means quality of the supplier is not good, then you will not purchase any raw materials from the supplier. So to decide whether the supplier is perfect or not, you have to inspect the inputs or raw materials. And usually statistical quality control is QC. There are three categories of statistical quality control. Number one is descriptive statistics. Number two is statistical process control. And number three is acceptance sampling. So this is the process of operations management: inputs, transformation, and outputs. When you are taking inputs, you will check some components, or you will take a sample from the inputs and you will check the quality. It is known as acceptance sampling, the last one. Acceptance sampling. And when the outputs will be produced, you will check some of the outputs whether the output is perfect. It is also acceptance sampling. And process control means while transforming the goods from inputs into outputs, we use process control. Statistical process control, second one. And first one is just the descriptive statistics. In our previous lecture, we have depicted some, figures. If you can remember, say for an example, fishbone chart or diagram, or different type of frequencies, frequency analysis, average analysis. These are known as the descriptive statistics. When we'll use statistical quality control, we'll use descriptive statistics, we'll use statistical process control, and also acceptance sampling. Statistical quality control, the term used to describe the set of statistical tools used by quality professionals. SQC encompasses three broad categories of descriptive statistics, which include the average or mean, standard deviation, and range. Involve inspecting the output from a process. Quality characteristics are measured and charted. Helps identify in-process variations. Say for an example, if we go to the classroom, then we can say, what is the average student? What is the age of the average student? Or what was the average age of the class? Standard deviation, sorry, mean. And then you can check the standard deviation, plus minus 2 or plus minus 3. Or also, as alternative to standard deviation, sometimes we use range. Range means the difference between the highest and the lowest. Say for an example, in your classroom, if the oldest one, that means who is, maybe your average age is 20 or 21, and the highest age is 23, and lowest age is 17. So this range is sometimes used as alternative to a standard deviation. And statistical process control, usually, if you can remember, control chart, there will be an upper limit, there will be a lower limit, and in between the data or all the observations will fit. This is statistical process control. And acceptance sampling, used to randomly inspect a batch of goods to determine accept or rejection. Does not help to catch in process problems. This one. Quality control. So these three categories of statistical quality control tools we use in our class, or when you will be professional, you will apply it there in your organization. Descriptive statistics, the number one. These are the descriptive statistics usually used in business operations or the production operations for quality control. Descriptive statistics includes number one, the mean, measures of central tendency, and you know how to calculate mean. X bar equal to sum of x divided by n. Range, the difference between the lowest and the highest observations. Difference between largest and smallest observations in a data set. This will not be or this will be n, between largest and the smallest observations in a set of data. Standard deviation measures the amount of data dispersed around the mean, plus minus 3, that we have already explained for you, and I think you got the idea. Your average age is 20 and standard deviation is plus minus 3. The amount of data dispersion around the mean. And we calculate standard deviation using this formula: summation over xi minus x bar squared divided by n, or n minus 1 or n minus 2, all are perfect. There is no problem. Usually we use n minus 1 to measure the standard deviation. And distribution of data shape. Distribution of data shape means that whether the data is normal or whether the data is abnormal, skewed. Abnormal means skewed, positively skewed or negatively skewed. What is normal distribution or bell shape? Do you have any idea about normal distribution or bell shape? Yes, you have. Normal distribution. You know, if the dispersion, this is average, and this is look like almost a bell. This is the normal distribution. That means the dispersion, the standard deviation. Dispersion means standard deviation. The standard deviation will be around the average. Here is the average curve. Here is the average curve, and the data points will be around this curve. 50% or around 50% will be positive plus, and around 50% will be negative. This is known as the normal distribution. And abnormal or skewed distribution means this may be positively skewed or this may be negatively skewed. Say for an example here, this is positively skewed, and this can be negatively skewed. Negatively skewed means that your more observations are here than positive. So if you think it is the average line, this is positive. So the data can be skewed rather than normal. However, when we measure the statistical quality, then we usually think that it is normal distribution. That means your average will reflect the standard deviations equally. Equal distribution of deviations around average is known as the, normal distribution. So descriptive statistics is clear, is it?
Yes, sir.
Then statistical process control methods. And one of the most powerful statistical process control methods is control charts. All the manufacturing companies use statistical control charts. And these control charts help them to identify whether there is any problem in the manufacturing process. Say for example, they are producing output here. Producing output when one of the observation number 6, say for example, is going out of control. Out of control, it means that in the manufacturing process, there is a problem. After getting that type of, observation or the observation that is out of control, the operations manager checks the system. What happens there? Why the output is coming out of control, and they take necessary measures. So the control chart ultimately say that there will be an average or central line, the average age of the students, and there will be standard deviation. Standard deviation is here, upper control limit is 0.2 and lower control limit is 0.8. That means plus minus 0.2. Plus minus. However, there is a system of calculating for if we compare it with our average age plus minus standard deviation, but there is separate formula to calculate upper control limit and lower control limit based on the observations or data or the information available to the company. Control charts for variable. There are two types of control chart. You can develop control chart for two types. One is control chart for variables and another is known as the control chart for attributes. The difference between attributes and variables are used to monitor characteristics that can be measured. Say for example, length, weight, diameter, time. Variables that vary. And control chart for attributes are used to monitor characteristics that have discrete values and can be counted only, cannot be measured. Say for an example, percent of defective, number of flows in a chart, etc. So variables deals with the quantity values or characteristics that can be measured. Length, you can measure length. What is the length? 5 feet, 6 feet. Weight, 5 kg, 6 kg, 7 kilogram. Diameter, time, etc. These are the variables and control chart for attributes. Used to measure characteristics that has discrete values. Discrete values means, say for an example, out of 100 items, what percentage of are defective? This it answers yes, no, defective or not defective. Number of flows in a chart. How many number of flows in a chart? 5, 6. So these are usually used to calculate defectives item. Usually the control chart for attributes used to quantify the defective amount in the production system or the amount of defects in the total output. More examples will make it clear. So for example, we are now dealing with control charts for variable. What is control chart for variable?
They're used for characteristics.
Characteristics that can be measured. Variables means what is, the definition of variables. Variables means is varies. The values varies or ranges are there. Say for example, weight 5 kilogram, height 6 inch. So variables, usually we use variables, and the control chart for variables, the measurement tools for control chart for variables are X bar chart and R bar chart. X bar means average, mean, and R bar means range. Range chart, also known as mean chart and range chart. Use X bar chart to monitor the changes in the mean of a process, central tendencies, average. Mean or average or central tendency is reflected here through X bar, summation of over Xi minus X bar. We will use X bar to develop control chart. Control chart for variables means that we will use mean or average to develop control charts, and use range bar. Range bar means we'll use range, the difference between the largest or smallest, highest or lowest values to develop the control charts. Use R bar charts to monitor the dispersion or variability of the process. The example of control chart using, X bar. This is X bar chart. We use X bar here. X bar chart. Constructing an X bar chart. A quality control inspector at the Cocoa Fish Soft Drink Company has taken 3 samples with 4 observations. So taken 3 samples with 4 observations each of the volume of bottles filled. So volume of bottle fills, that means it is variable. Weight, it is volume of bottle fills. If the standard deviation of the bottling operation is 2 ounces, this type of standard deviations usually developed by the operations manager only. Standard deviations, and use the below data to develop central control chart with limits of 3 standard deviations for the 16-ounce bottling operation. So the company is producing 16-ounce bottle. So what you will do, you will develop a control chart. When the operations manager or the production officer or the floor officer will measure the amount of drinks in a bottle, they will check whether 16 ounces or there will be a control limit, upper control limit and lower control limit. Whether the amount of soft drinks inside the bottle is within the control limit. If it is out of the control limit, then if you read the book, you will find that this type of companies use, robotic operations to measure the amount or quantity of the drinks in a bottle. So when they measure or when the machine or the robot measures that it is not within the acceptance limit, then it throws out to the other defective line. Defective line. So the quality control chart is not theoretical. This is totally applicable, and all manufacturing companies are using control chart. So here, come back. There are four observations. There are four observations, and you have taken three samples. First time you have taken four observations. Second time you have taken four observations. Third time you have taken four observations. That means these are the samples: sample 1, sample 2, and sample 3. And these are the observations: three samples and four observations. First, you calculate the average of the sample 1, then average of the sample 2, then average of the sample 3. And average calculation is very easy, the sum of these figures divided by n. So total here, if you sum up, the figure is divided by 4. There are 4 observations. The average is 15.875. Here, for sample 2, the average is 15.975. And for 3, it is 15.9. And also ranges are given. The range, you can calculate which is the lowest and which is the highest. Here, lowest is 15.8 and highest is 16. 16. 15.8 is the lowest and 16 is the highest. So range is 0.2. Here, highest value is 16.1 and the lowest value is 15.8. So range is 0.3. Here, the highest value is 16 and the lowest value is 15.8. So range is 0.2. So if we have the information, the sample and the observations, you will calculate the central line and the control limit. How to calculate the central line? Central line means you will central line, as we refer, is average age of the students. Here you will also calculate the average of the averages, because sample average, second sample average, third sample average. You will measure the average of the averages. So X bar, instead we use X double bar. X double bar means it is X1, X2, X1 means this average, X2 means this average, Xn means this average. So this average means sample averages and divided by K. K means, here the K is the number of sample means. So number of samples or sample means 1, 2, and 3. 1, 2, and 3. K. Instead we use K, not N. So using the control limit, using the X double bar, can you calculate what is the average or central line here? Central line. Do you have pen, papers with you?
Sir, what is the value of K?
Sorry, can you be louder?
Sir, what is the value of K?
K is the number of samples,
Oh, okay.
or 1, 2, and 3. So you are measuring average of the averages. So how many averages are there? 1, 2, and 3. All right. Okay, remember that K indicates number of samples and N indicates number of observations. Here it says, so here K is the number of sample and N is the number of observations.
Sir, is the answer 15.91?
Okay, 15.91. So X double bar is 15.91.
Yes, sir.
Okay. And then standard deviation, you will also calculate the standard deviation of the averages. In that case, what you can do, we have explained here. The standard deviation is given here. 0.2 ounces, and you will use this population standard deviation. The information that is given here is ultimately population standard deviation. We can use this standard deviation to calculate to develop the control chart, and sigma x bar equal to sigma root over n divided by root over n. Root over n means number of observations. There are 4 observations. So upper control limit, when you will develop the upper control limit, central line is double x bar, central line, and upper control limit is x double bar plus z means standard deviation. 3 standard deviation is explained here. So g means 3, and sigma x bar you will get it from here. And lower control limit, it is just minus. In place of plus upper control limit, you will deduct it from the z sigma x bar. Then you will get the lower control limit. Check the answer here. 15.92. So your answer is all right. 91. 91 is maybe you haven't used some approximations.
Yes, sir.
So 92 and control limit for 3 sigma limits. So this 3 sigma limit is stated in your problem. These are given because these are developed by the operations manager over the years. It is not just the standard deviation of the samples. This is the standard deviation of the company for about few years, or popularly known as population standard deviation. And this is also population standard deviation of 0.2, and it is 3 means 6 sigma. 6 sigma means the standard deviation we use in normal distribution. 3 normal distribution. So control limit for 3 sigma limits means x double bar plus 3.2 root over n. Root over n means number of observations, not the number of samples. Here, number of samples. There are 3 samples. 1, 2, and 3. And observations are 1, 2, 3, 4. So here, calculate the x double bar, or the average of the averages. We'll use number of samples and to develop the upper control limit, and lower control limit will use number of observations, root over 4. So upper control limit is 16.22 and lower control limit is 15.62. That we use in our example. If you can remember, average age of this train 20 plus minus 3. So one will be plus, another upper control limit will be 23 and lower control limit will be 17. All right, plus minus 3. And you can develop such control limit. It is the central line, and it is the upper control limit, and it is the lower control limit. All the observations will be here. All the observations will be here. If some observations are out of here, then the operations manager will check that the product quality you are producing is out of control. So why the outputs are going out of control, you have to check. And if the amount of soft drinks inside the bottle is in between these points, there is no problem. There is no problem. So have you got the idea what is control chart for variables?
Yes, sir.
So we are developing control chart for variables. Whether you will use control chart for variables or whether we will use control chart for attributes, it depends on the it depends on the product characteristics. Depends on the product characteristics. Or in case of attributes, usually we say yes or no. Say for example, defective item. It is defective. That means yes, or not defective, no. In such type of decisions, will use control chart for attributes. But bottling operations, weight or height or characteristics that can be measured, we'll use control chart for variables. So here is another one more problem. A quality control inspector at the Crunchy Potato Chip Company has taken 10 samples with 4 observations. Here number of samples are 10. That means this is K. And observations in each sample, there are 4 observations. 1, 2, 3, 4. 4 observations. Sample 1, 4 observations. Sample 2, 4 observations. Sample 10, 4 observations. 1, 2, 3, 4 observations. Company has taken 10 samples with 4 observations, each of which volume of bags filled. The data and the computed means are shown in the following table. If the standard deviation of the bagging operation is 0.2 ounces, use the information in the table to develop a control chart of 3 standard deviations of the bagging operation. So what you will do, you will first calculate the average of the averages. Here, it is the average of the first sample, average of the second sample. So you will sum up all the averages, and it is equivalent to 125. It is equivalent to 125. And the number of samples are here 10 divided by 10. So average of the averages is 12.5 ounces. The control limits are upper control limit Z sigma X bar plus. So 0.2 ounces is given, and we will calculate control limit for 3 standard deviations. 0.2 divided by root over 0.4. 0.4 means number of observations. 1, 2, 3, 4. There are 4 observations. 4 observations, and the upper control limit is 12.80 and lower control limit is 12.20. So the control chart will be, the central line will be 12.5. That means if you draw the control chart, this central line, it will be 12 and sorry 12 and half, and the lower control limit will be 12.2, and upper control limit will be 12.8. It is known as the control chart. And if any observations go out of the upper or lower limit, then the operations manager will inspect the operations and will make decision. So, sorry. Can you solve it? Try to solve this problem.
Sir?
Can you solve the problem?
Sir, first we have to calculate the mean and then calculate the mean of the means, right?
Right.
Okay, sir.
There are mean is calculated here, x bar.
Oh, okay.
So you calculate the average of the averages. That means central line. There are 5 samples and 4 observations. Also, the word we use, mean of the mean is also known as grand mean here. Mean of the,
We have to calculate the upper limit and lower limit as well.
yes. Everybody should, develop the control chart. Although the calculation is very simple, but the most effective tool the operations manager use, because every day they do not check the system. They check the system when there is any problem. Problem, that means when the output of the product is out of the control limit, then they check and take the corrective actions, or they refer it to the quality control team. Jeta amader Daming has specified by that there will be a team, and in our Six Sigma total quality control quality control system, we have also said that there must have a special team. They will ultimately solve the quality related issues. For all, are you trying?
Sir, is the central line value 12.11?
Okay, you calculate the upper and lower limit. Then we are gonna check the solution is given here. Mr. Zubair Siddiq, are you here?
Yes, sir.
Are you solving the problem?
Yes, sir.
Okay, tell me what is the grand mean? What's the grand mean here? Mr. Afif Ahmed.
12.11, sir.
Mr. Tawhidul Anik.
Yes, sir.
Afif Ahmed. Josh Shah. Mr. Josh Shah.
Yes, sir.
So what
Yes,
is the
sir.
grand mean here?
12.11.
Okay. Then what is the upper control limit?
Upper, sir. 12.14.
12
14.
and lower?
12.08.
Is it all right? So let's check the solution. Your average is 12.11 and upper control limit is 12.14 and lower
12.08.
control limit is 12.08.
12.08.
So this is how the operations manager develop the control chart. And the 3 standard deviation is almost constant because all managers use 3 standard deviation, or you know that this is known as ultimately 6 sigma. 6 sigma plus 3 minus 3. Now come to the control chart for range. আর আপনাদের attendance দিতে হবে নাকি?
Ji sir.
Okay, attendance আমি এখান থেকে নিয়ে নেব কারণ তো আমার কাছে record I am taking records of the lecture. Number 1, number 2 is that the system will take records who have joined and who have not, and who have joined and left. All records are here. Zoom will record everything. Now, control chart for range. Control chart for range, what does it mean? Range means, the difference between the highest value and the lowest value. And what you have to do to develop control chart for range, you have to use R bar. R bar means average of the ranges. The range for the first sample, if you go back to your first example here, this one, these are the ranges, the difference between the highest and the lowest value. Difference between highest and lowest value here 0.2. Difference between highest and lowest value is 0.3, 0.61 is the highest, and 15.8 is the lowest. Difference is 0.3. The difference between the highest and lowest value is 16 minus 15.8 is 0.2. So we will calculate the average of the ranges. We will calculate the average of the ranges 0.2 plus 0.3 plus 0.2 divided by number of samples 1, 2, and 3. So you will same. We will divide by k, not by n. So after getting the average of the ranges, what you can do, you can use this factors for 3 sigma control limits. These are the 3 sigma control limits factors. And for ranges for R chart, usually we use D4 for upper and D3 for lower. And for X bar chart, we can use this chart, say for example, A2. A2 can be used, but we have already calculated manually without this chart. So you can use the chart. There is no problem. The answer will be same. But for R bar, we will use this chart because of the standard deviation and the other measures will not work here in some in range bar chart. So upper control limit equals D4 R bar. So we'll go to D and R bar. R bar is 0.22. So D4. D4 means we need to know what is the number of samples. We'll go to the D4 and number of observations. Here the number of observations are 4, isn't it? In our first example, we are talking about this example, this one. What is the number of observations here?
4.
4 number of observations. So we'll go to 4 and then we'll use the standard 3 sigma. 3 sigma, we'll check it. So 2 sample size 2, 3, 4. 4 and D4. D4 is 2.28. Is it? D4 is 2.28. We will take this figure here, 2.28, and multiplied by the R bar, 0.53. Are you getting how to control upper control limit using R bar chart?
Yes, sir.
And lower control limit is D3. Just it is the D4 and use the D3 is lower control limit. D3 is 0 here. So you are taking 0, the answer is 0. So when you are developing control, control chart, you will use the R bar. Here it is the R bar, and upper control limit, lower control limit is 0, and upper control limit is 0.53. 0.53. It will be somewhere here. It is drawn, not properly drawn. The upper control limit will be somewhere here. Sorry. 0.53. This is wrong. Here and lower control limit will be 0. This is all right. All right. So here it means that when there the figure will be out of control, means here there are below 0. Usually there will be no below 0 figure because it is ounces, bottling operations. So when you will use the R bar chart to develop the control chart, you can use the R bar, sorry. Use these factors for 3 sigma control limits. 3 sigma control limits factors. This is all about today's, how to develop control charts for. Okay, there is a, can you develop control chart for using R bar? Here 10 samples with 5 observations have been taken from the Crunchy Potato Chip Company plant in order to test for the volume dispersion in the bagging process. The average sample range was 0.3 ounces. Develop control chart for the sample range. Can you develop? R bar is 0.3. The average sample range was given 0.3. R bar is 0.3, and number of sample is 10 samples with 5 observations. N here, N K equals, samples, and N equals number of observations. So using the number of observations, can you calculate? So what is the D4 here? Which one will you take? Check once more. 10 samples with 5 observations. Will you take 5 observations or 10 samples? In range chart? Can you hear me?
Yes, sir.
So which one you are gonna use?
Sir, the samples.
5 observation.
You are going to use number of observations. So D4 for 5, number of observations here. Here number of observation is 5, and value of D4 is 2.11. This sample size doesn't mean number of samples. Number of observations, because these have developed considering only one sample. And you know that when you do any type of research, you take different samples, and sample number is known as the observations. So here the D4 is 2.11 and D3 is 0. For N 5, D3 is 0. And you can calculate the upper control limit to 11 multiplied by R bar 0.3. It is the upper control limit, and lower control limit is 0. The factor value is 0, and you will multiply it by 0.3, the average ranges, and it is 0. So upper the central line will be 0.3, upper will be 0.633, and lower will be 0. All right. This
Yes,
is how you can develop control chart. So if we sum up today's lecture, we can say that there are 3 statistical process control tools. The 3 statistical process control tools are: number 1 is descriptive statistics. Average, standard deviation, range, these are known as the descriptive statistics. Another is statistical process control. Another is statistical process control. You will control the process, and to control the process, you have to develop process control chart, or that we have developed here, this type of chart, control chart. And we can develop control chart for 2 different types of outputs. If the output is measurable, that means if the characteristics of the output can be measured by length, weight, height, etc., then we'll use X bar chart or R bar chart. Both are same, X bar chart or R bar chart, range chart. And we can use also acceptance sampling. And acceptance sampling means you will take some samples. Here samples means observations. You will take some samples from the output or the raw material inputs, Then you will check whether the quality is perfect or imperfect. Then you can use, acceptance sampling for testing inputs or outputs, and process control, because operations management means